get started. So, yeah, I was asked by Maria a few months ago about this workshop, and we're excited about it, the idea, because one of the early days, and I prepared a couple of talks. I wasn't sure exactly what the background was of the audience, and so I guess I'm gonna make it audible right now with Maria, and I could give a talk about a meta talk about backyard brains. It talks about a little bit about the DIY neuroscience aspects and how do you how did we start a company and how did we build? Because I feel like that's interesting in the form of alternative science careers. If our goal is to become scientists, there are multiple avenues for people, and one of which is going to the university and becoming a professor. But there is a growing interest in this other field, which is kind of this a kind of entrepreneurship as a way of doing science. And so I thought, given the fact that some of the discussions I had with Maria before, I might start with that, and then what we can do is move closer into some of the theory of the kind of like what is it we're actually doing. So some of the, I guess, not more of the practical aspects of backyard brains, and we can discuss some of the experiments that we're developing now that will be coming out in the future, and then that revolves more around AI and about machine learning and about computational neuroscience. So I think that will be the approach I'm going to do. So I'm going to start, unless I have any disagreement. Would you guys rather just see so I can also just do a talk about our experiments. But it looks like from what I saw on the agenda, you guys have already done some of that. I saw a blabberous discoitus cockroach leg discussion. So maybe it's best to start with this one, and then I can open it up, and I have everything here, so we can have discussions about various aspects. We can do some experiments live, and we can try to dive in a little bit more. Does that sound good?
Yep.
All right. Cool. And then eventually one day I'd love to come down there. That's why I was really looking forward to that, but unfortunately did not happen. So I'm going to open up the video here. So I'm going to say, okay, so I just wanted to just discuss about where backyard brains came from, because it is kind of a weird idea. And so this was Tim and I. So you've met Tim, I believe, already in the course. And when we were grad students, we had about $40,000 worth of research gear. And I remember it being a student walking into a research lab for the very first time, a neuroscience lab, and hearing a spike in a rig, that exact rig, because that was the first place I actually saw the neuron on. But I remember walking, I was interested in neuroscience. I didn't quite know if I wanted to be a neuroscientist, but I was kind of curious about it. So I went and talked to a researcher at a lab. And I walked over to this magical rig, and I looked into that magical box, and I saw a rat there. I actually saw him on a video monitor. We had a camera in there. And every time the rat would move its neck to the left like this, I would hear this really distinct brrr, like a popping sound. And if he moved it slowly, it would have this other, and at that point, I had lived an adult life. I was 35 years old, and I had no idea what was going on when I was watching this thing. And I kept asking, what is that? I said, that's a neuron. The neuron's controlling that. What do you mean neuron? I kind of know what neurons are, but I didn't know what this digital, it seemed a very, very weird signal, this spike. And when I heard that, I knew that my life was going to be dedicated towards whatever this weird thing is that I saw, because that was the key piece. So when I heard that spike and saw that spike for the very first time, I was hooked, and I just couldn't stop, but just trying to understand what these neurons were doing, that my entire body, like all of my hopes and dreams and desires are all encoded by these neurons. It's funny that, because in grade school in the US, we are never taught about neuroscience. And so we didn't learn about it. I learned about the brain, and I learned about that the brain controls, emotions and stuff, but never in the details that we know. I mean, that scientists have known. And so to me, it was a big eye-opening experience. And so anyway, so that's just where we started. And so that was Tim and I in our labs. And so we were doing around that time, this idea that, you know, given the fact that so many people have a neurological disorder, why is it that we have to spend, you know, our entire lives just to get access to a lab that has $40,000 worth of gear to start to ask questions about the brain? And we can look at, for example, in astronomy, you don't do that. You as a kid, you can go out and buy a cheap telescope. You can set it up in your backyard and you already start collecting data, right? You can start making some predictions maybe, or maybe you just find out that's not for you and you put it away. But with neuroscience, the only way to find out it's not for you is to kind of spend your entire life going, like, working towards this degree, right? And then you get your PhD, you finally get access to the tools to understand how the brain works, and then maybe you realize you don't like that. So it seems a bit of a silly approach that we do in neuroscience. So that's where we came up with the idea of this thing which we called, back then we didn't know the name for it, we just called it a $100 spike. And so we had a self-imposed engineering challenge, and we decided that we are going to restrict ourselves to $100, and we're going to keep track of all our receipts, and we're going to be able to try to record a spike, which is an action potential, for under that amount. And so in order to do that, it required some creativity. So we had to look at a different animal model that we could then use. We can't use humans, obviously. We can't drill into human brains, and we can't drill into, you know, a dog's brain. So we made the switch into invertebrates, into at that point we were working with crickets and cockroaches as well. And so we were doing that, and we had this little idea, and it was a self-imposed engineering challenge that we started in around like the beginning of the year, so like around March or April, which is right when the abstracts are due for Society for Neuroscience. And in the abstract, we just said, you know, we're going to attempt to record a spike for $100. Please stop by our poster after the summer and see how we did. And if you've ever submitted to SFN, it's due in March, and then the conference isn't until October, November. So you've got almost an entire year between when you submit your abstract and when that poster's done. And so we decided to choose that time as the limit. So we have this amount of time to invent. And so then if you were to stop by our booth at SFN, you would have seen Tim and I with looking much younger than we are today, with a couple of demonstratable components here. And so we have a micro manipulator that was made out of like wing nuts and wood. And we had a circuit board that could record spikes. And so one thing that I should mention is that before this, Tim and I had a series of satirical posters. So we would do, they're not really joke posters, but they were funny, but they always had a point to it, right? So we would present our rat data and do correlations against the stock market to show that the rats were controlling the stock market. And we would do that not to show that the rats are controlling the stock market, but to show that there are some inherent problems in the way that fMRI data was being analyzed. And if you don't do Bonferroni correction, you can get spurious results. And so we saw that in a number of papers. Instead of writing a poster about we should do Bonferroni corrections, we did a poster on the rats controlling the stock market. And so we would publish each one of those papers in peer-reviewed journals. And so that one was published in Annals of Improbable Research, AIR. It's what does the Ig Nobel Prize out of Harvard. And so they loved it because they got the idea. They got the idea that it's humorous at first, but then you start to think about it and well, shit. If that's not true, we don't think rats. So what's happening with all this fMRI data, right? That's coming out. So then, but I will say that the fMRI people have cleaned up their act, and they now do statistics a little bit better after the first few years. So we did a series of posters like that. We were always kind of making fun of ourselves or making fun of our fellow scientists. And so when we did this poster, we had 4 years under our belt. So we were pretty good at pretending to deliver satirical stuff with a straight face. And so the story we told for this Backyard Brains poster was of a zombie apocalypse. So the story was a zombie apocalypse has occurred. Your loved ones have turned into a zombie. And so we had to come up with a cure. And we know that it's a neurological disease because the zombies have affected their behavior. Therefore, we have to study their brains and nervous system to see what's affecting it. And all of the vendors have turned into zombies. And so we can only break into Radio Shack at night and steal components. And that's why we were building this poster. So an absolutely ridiculous idea, but it's a much more compelling thing than a single channel low cost bioamplifier, which would have gotten nobody to stop by. But when we did a zombie apocalypse, we had 6 people deep at our poster booth. So, and then it got picked up by the journal Nature, and we were on the Nature podcast. And all of a sudden, the week after that podcast came out, I started getting emails from people, and the emails were like, "Hey man, you know, I really love what you're doing. You and Tim have a really great idea. Can I buy one of those kits? You know, can you?" And the original idea was not to actually sell it or to start a company. It was just kind of a hipster thing to kind of do it to yourself. But then we kind of realized that there's other people that were like us that wanted these things. And then slowly over time, you know, I was doing research, which I thought was, I still think is pretty important, these fast spiking interneurons in the basal ganglia. And I was publishing high profile papers, but not once did I get an email about, "Hey man, I really appreciated that, you know, that FSI paper you did. You know, I think those LFPs, keep up the good work. I think it's so important that you're doing this research." No, never gotten, I don't know if anyone's ever read my papers, right? Except for the handful of people that are in that field. And so this idea of getting this feedback from a side project was kind of new. And then it just, at some point, you know, it's funny because I studied basal ganglia. And so at some point, if you keep getting rewards on this other thing, you're like, well, maybe, you know, this side project should be the real project. And so around that time, we launched this company called Backyard Brains to mass produce these things. Well, mass produce was like in the tens at the time. As a grad student, Tim and I formed a company. We called it Backyard Brains, and the idea was to take the phone, which had just come out the year before, and use that as a recording device and plug our spiker box into there so we can reduce the complexity of the device, because you already have the complexity in your hand, and therefore we can make it cheaper and make it available for everyone. So that's how we started the company back in 2009. So we've just celebrated our 10-year anniversary. So believe it or not, this idea has survived 10 years. I'm still a little bit in shock. So what we did is we took that idea and we submitted it to a University of Michigan had a Dare to Dream program. It was for entrepreneurs. And so this kind of got us the idea, like a little bit of seed funding. So I remember we got $500 as an award for winning, I think, second place in this entrepreneurship prize. And we went away and bought immediately parts to build boards, and we sold those to make more money to be able to do more research on that one. So immediately went to work on that, and then used some of that money to buy the online lawyer thing to be able to register the official company. So that's how we got officially done. And so then we decided that we wanted to really start this thing, that was going to be the next phase after grad school. And so after I graduated in 2010, I started working half-time as a postdoc, half-time for Backyard Brains. I didn't get any money from Backyard Brains, but I was just kind of working there more time. And so these are the first boards we produced with that money that we got from that Dare to Dream grant. And so I remember we sent one to UCSD. That was our very first one. And then we started to grow from there, just through the small bits. I remember this is another moment of our life in 2010 where we put the website up and we got the very first order on the website came from UCSD, and we were surprised to hear that. And the funny thing is that one of these people on the that were on that first order, Emily Caparello, is now my program officer at the NIH. And so she's in charge of our program now to produce the spiker box. And she was originally the first spiker box purchaser from us. So it's kind of cool that we've outlived the something, and now our proteges are our bosses. So anyway, that's kind of cool. And so we moved in from our garage into a startup space. And so with the University of Michigan's entrepreneurship program, Tim and I got an office, and this is a picture of Tim and I in 2009 or 2010, right when we got our first office, and it looks like we're falling in love with each other. But really what we're doing, we're listening to spikes. And that kind of was the launching. And so then we went out and we tried, all right, we're going to be a company. We're going to go out and pitch to everybody. So we won a bunch of contests to go pitch your ideas to Silicon Valley. We went to Y Combinator. It's the most famous startup incubator in Silicon Valley. And we pitched our ideas to investors, and the investors all told us, good luck, boys. You know, there's no money in education. You might be able to, you know, make a few bucks here and there and do it as a hobby, but there's no market for you in education. So we were undeterred. We felt that they were wrong. And so we continued to do some work, and we were submitting videos online to various competitions that were doing it. And so we went to Startup Chile. We moved down to South America because we got a grant from them for $40,000 to move down to South America. And so Tim now speaks fluent Chilean Spanish, and I think he still technically lives in Chile. He's currently in South Korea, but so we now have offices down South Korea in Chile. And we have all of our experiments have been translated into Spanish, and we're starting to do stuff there. But it wasn't until the next thing that happened that really stepped us up. So we now had a larger amount of money. We had $40,000 of which we could start to pay ourselves and start buying more equipment. So we were buying a bunch of equipment at that point, and then trying to just manufacture the ideas and try to get them back into it. So that's how we started. So this is where we went from our early prototypes that we had at that SFN poster, and we did some designs, and we ended up getting too small, and we got back to the look that you might be familiar with now, which is like a sandwich board. And we end up moving away from wood to acrylic because we wanted you to see in and see what was going on. No magic, right? So that was the idea. So that's how we got to kind of where we are. And I will say that everything changed when we got this email from the NIH. So we got this big grant, like $100,000 grant. And that meant I could officially quit my job at the university. I think I got 10% at that time. And then we could hire people. So we hired 2 people, and we felt this pressure to actually, somebody believes in us, and then we got to make sure this thing works, right? And so, and I joke because this email that came in is literally NOA1R43 and then nothing is mentioned here. But if you open up this file, which is called temp2751.pdf, that's the only way to find out that you are awarded almost $1 million from the NIH. So anyway, just if you're ever going to, don't delete your emails if you're going to be submitting, because this was easily could have been characterized as spam. But anyway, so that's how we got our money. So this was almost $500,000, almost $500,000 was in a temp file inside of our stuff. So then everything, boom, we had money. And so then we hired people, we had a booth, we made product packaging. We kind of, so it's just kind of still the stage that we are right now. We're still a scrappy young company. We haven't really grown to the point where we're completely self-dependent yet. So we still have to write grants. But I'll give you an idea of what we have done. And so we've been able to raise almost $6 million in grants. That's amazing, right? From these stupid ideas of of kits for kids in school. We've been able to convince the government, the NIH, that this is an important field, and they've been able to fund it. And so we've gotten a series of grants over, not just this. It's not just one grant. This is a collection over 10 years. And we've been able to raise almost equal amount in revenue. And to me, it's sort of like a trade-off. It's like if we're doing something of value to the world, then I feel like we should at least be able to get paid back as much as the government put in, right? So we're almost there. We've got $5.6 million in sales and $5.9 million in grants. And so I feel like at some point this year, or maybe early next year, we'll make that switch. So we will have been a success in the eyes of the government because we are generating tax revenue more so than they've given us money. So anyway, so that's kind of cool. And then, of course, we have social impact as well. We have 9 TED Talks and a whole series dedicated to our stuff. You know, we've sold 43,000 spiker boxes. So people have recorded spikes, possibly hearing for the first time a spike and maybe becoming interested in becoming a neuroscientist like I did, right? And so, and we have, I think now the last count was like 13, that's over a dozen, 13 peer-reviewed papers that have been published from us in looking at the educational aspects of the spiker box. And I will tell you, in that category, there was a paper that we published that we didn't really care about because it was just kind of a one-off thing that didn't make much sense to us at the time. But we did a study with Harvard very carefully controlled study where we had one group of students was given the spiker box at home while they're watching the videos in an online course from Harvard. And then another group of students that just watched the videos online and didn't have to do the experiments. And we did a very careful study, and we looked at all these different educational aspects. It turns out, as you probably would guess, if you actually do the experiments yourself, you increase your self-efficacy. It means like you are more self-confident in the material that you're learning, and you're more self-confident about understanding the material outside of that in neuroscience in general. And so the content was the same. You could learn about neurons in both, but the feeling that you could do this in the future, which is the important part of education, it's that thing that turns on your brain. Holy shit, I could do this. Like that part was missing if you just watch somebody else do it. But if you did it yourself, you could. So I just want to mention that one because it's with COVID-19, a lot of people are just doing online stuff. And so I think it's important to remember that we still have to do labs and still have to do other stuff. Okay. And I will just end with this section of it before we go into some of the more science-based stuff is talk about why is that, like, if you guys are scientists and you want to be scientists, that's one thing, but why entrepreneurship, right? And the one thing that I could never put, because I'm not motivated by money, and so obviously I chose a career in science. Right? So it's not like what you're doing, but there is something rewarding about getting paid for something that was in your brain, right? It's a validation that you did something of value that someone will hand over money for you to get that. And so that was not. It was not clear to me that was a big motivator for me, but it turned out that it was. When I would get those sales, I'd just be happy, not because I was rich. We're not getting rich on these things. We're because it just meant that, wow, somebody actually valued something that we built, and they're going to use it and they're going to get value. I don't know. It sounds kind of cool. The other reason why I thought entrepreneurship was cool is that you basically become a PI right away versus doing a postdoc and a second postdoc and then doing like working at a small university, moving your way up to a larger one and getting tenure. You basically start off as a tenure track faculty with the ability to write grants and to do these types of things and make decisions about your lab, right? And that's something that is kind of rewarding. So you can, especially for me who was starting my career late, I could jumpstart in and become a PI more quickly. And the other thing I want to say is that as grad students, we all have special talents. We think about things differently than the rest of the world, and especially with the entrepreneurship world. And so I think we offer some special insights into entrepreneurship that is not found there. So that's kind of cool. And then the other thing is there's lots of money available for it. Governments are, in some sense, foolishly tripping over themselves to hand out money to entrepreneurs with the hopes that you can plant those seeds and then grow the economy that way, right, by doing that. And so in a sense, it worked in Chile. We took money from Chile, $40,000, and now Tim has spent the last 9 years of his life there employing people. And so so that kind of paid off for Chile. But it's not just Chile, it's obviously the NIH here in the US, but there's regional ones all around the world. Tim is in South Korea for the same reason. He took a startup grant over there. Now we're looking at maybe expanding there. And now there's ones in Dubai, there's ones all over. So if you have an idea that's decent, there's plenty of opportunity for you to get funding to actually make it just like we did. And so the other thing I'll say is that when you're starting these things, you don't have to start very big. Like we started very small at a poster and just sold one product and just had a few ideas about that. And then the last thing I'll say is that I think a lot of people leave academia to get away from academics. Like they don't like it anymore. They don't like all that stuff. But if you are like me, if you're still a nerd and you still like academia and you like the kind of the moral compass that it gives you, like this direction for doing research for the sake of research, you can still do that. So we still publish papers. I still am a reviewer in many journals. We present posters. We present symposiums. We co-author grants with other scientists. We write our own grants. So there's really, if you were to sit in on the day-to-day operations of Backyard Brains, it would be pretty hard for you to distinguish from other research labs, other than sometimes we have to deal with some business-related stuff like products running out of stock and stuff like that. But for the most part, what we think about internally are just ideas for experiments and how to develop that. So that's what I will say about that. So now I'll just give you an idea of where we are as far as our finances go. So this is, I didn't do 2020 because it was kind of not a really good representation. It's like, but this is kind of where like the slow growth of the company that getting up to a certain point. But to give you an idea, this is where our cost rates are. So everyone's like salaries are expensive and we have a bunch of people. So that's what we use the grants for to help pay off that stuff. And the orange stuff is our money that we're getting from customers, and that dotted line is what we're spending. And so that gap every year is covered by little grants that we're getting from the NIH. But the goal is eventually that's going to overtake the burn rate, and then we can just focus on doing science without having to write grants and just kind of have the intellectual freedom that was only awarded to maybe if you were born in like 1780 and you were like a English, I don't know, gentleman scientist. We're like, I just want to go. I'm going to decide to work on plants today, and now I'm going to work on something. You don't find that in science anymore, and because you have to be very, very focused because you have to get these grants. But if you can free yourself from that, then you might be able to answer some deeper questions that are broader, right? So anyway, that's another advantage of it. So anyway, I will be quiet about that. And I'd love to get some feedback about the rest of my time. I'm not even sure how much time I have left, but what I could do, I brought with me a bunch of kind of demonstrations of stuff, and we can have a discussion about where we're going with the future of the company. We can do some experiments. If you guys are wanting to see something, have some questions about a particular experiment, we can do those types of things. But I wanted to keep this a little bit more informal. So I feel like I don't really get a chance to chat that often with scientists particularly. So can I open up for a little bit of questions from this is to understand what I can do with the rest of my time.
Okay, I think that the students that are present, maybe their opinion would be worthy. What would they really would like? For me, for example, would be about what is the future and of what are you thinking about in developing the future. But I prefer the students to ask for what they prefer.
Yeah, no, I'll definitely talk about that. But if students have particular questions about ethical concerns or because we don't talk, that's one thing I wish we did. I can just briefly talk about that. One thing I could kick myself for is in those TED Talks where I'm cutting up roaches and stuff like that. I wish I just spent 30 extra seconds and just talked about ethics for 30 seconds, and that would have been enough cover. I think the fact we kind of glanced over that is a bit of a problem, and it has caused to be a lightning rod. And we've noticed that we don't have, when we present normally, we never have anyone in the audience that objects. But because we have a longer discussion about the cost benefit ratio of doing animal experiments, even on invertebrates.
Yeah,
Anyway.
I agree totally with you in two things. One that you have already mentioned is that when you make something with your hands and by yourself, it's much worthy than just looking at someone else doing. That's why in this workshop, every of the students receive one. At this one, they will receive another one because we obtain a second grant that may allow to send a second one for every student. So the idea was just the same, that they have the possibility to do the experience, and we are going to send you the recordings of the presentation of the students because they are very interesting, and also there are a couple of posters. And so in this side, we are very in synchrony, and also related to the ethics, because this workshop was a do-it-yourself neuroscience and artificial intelligence for all, but there was also a big point on ethics and neuroethics. We have a presentation from Arlene Salles, during the workshop, and it will be tomorrow in related to ethics and neuroscience. And tomorrow she will present.
Okay, no, so at least coming out because I feel like
and artificial intelligence.
Right, and so the one thing that it's so we're writing a book right now for MIT Press, and I've noticed the chapter I'm spending the most time on is the ethics chapter. I want to make sure that we nail that we just really are crystal clear on why we think what we're doing is ethical. And in there we're using this analogy of this scale, right? You have these benefits and costs. You want to make sure that it's not like bam, like it's like that it's not one side is like overly weighted, unless that side is benefit, right? So we want to make sure the cost isn't like much greater than the benefit to society. And so you can start to lay these things out. You can start to measure certain things, right? You can start to look at what is it we're trying to do. We're trying to explain to kids how the brain works. And so why are we trying to do that? Because of the economic and emotional pain that 20% of the world having of an incurable disease can cause, right? So that seems a pretty big cost. And actually, that's the benefit, because we can start to train students on this earlier to help recruit people to come in, right? But the cost to the animal is very, very small. We cut that leg off, and so Tim has done a very, very careful study by regrowing legs. I'm not sure if you talked about that, where he has, it's a very hard study to do. You cut off the legs and you just keep waiting months and months and try to keep them separated. You measure each one and you take how many days does it take to regrow? So we've carefully documented these things regrow. We've looked at, do they mate? Do they eat? Do they do other things that cockroaches like to do? And it seems to be that every measure you make, there doesn't seem to be a huge effect on the cockroach. Therefore, the cost is really light, but the benefit is heavy. So therefore, we felt this is ethical. And so you can ask that question pretty much about every experiment that is being done. You can kind of make that thing. So that's what we're working on. So I think we can, if you engage people, and I think you don't want to skirt around it. I did say something in the TED Talk very quickly, but I just wished I paused and just said that again, just to make sure that it was clear, because I think it's an easy thing to take you down on, and it's an easy thing to defend, but you're often not given the choice. You're often are against PETA, and PETA is just saying one thing, and then everyone starts spamming you with shit. So anyway, that's my advice, is to kind of make sure we talk about the ethics when we do this, especially in DIY bio. All right, so now for the future, and then I can wait. If there's a chat room, people can start. They can start typing in questions as well. How do I see that?
It's in...
Whatever. All right. So they can do that as well. And maybe you can let me know if there's any questions.
Estudiantes, students, do you want to make a question, comment? I can translate if you want.
Yeah. Also. Okay. I wish I would. Yeah, I would have thought about that. When I moved to Chile, I was able to say, hola. Mi nombre es Pereira y soy ingeniero y neurocientífico en estudio el cerebros de los cucarachas. So when I lived in Chile for 6 months, and I got to know enough to do a talk, but unfortunately that was in 2012 and I had forgotten it all. So if you can translate, and I'm trying to speak slowly, but I have ADD and I tend to speed up, so I'm trying to be careful not to do that. So if I'm too fast.
Yeah. And another interesting thing is in this group that there are master in science students, there were PhD students from different countries, but also science teachers from secondary school.
Yeah, so let's have it. So I want to talk about the future, because I think we've pretty much, outside of that, right now I think our experiment base is good for electrophysiology. The problems now are chasing down the kind of how do I say it? It's like the technology race, right? So like phones keep moving ports and changing technology. We have to keep kind of changing those things, and so that's driving a lot of our hardware changes. It's just like the technology that we're connecting to. But as far as the experiments go, I think we have over 50 experiments now that does electrophysiologies. We're still adding new ones, and it's exciting. So every year we try to add 10 at least new ideas. That's our goal going forward. We're moving our company into an idea manufacturing instead of parts manufacturing. So we're going to try to downplay, right? For the first 8 years, we were hand soldering every board here in Ann Arbor. And we thought that was cool because we were like, you know, hipsters, like building it. But then we realized that customers don't care. They don't care that we built it ourselves. They care that it works, and they care that the experiments work and the experiments are good, right? So we were spending all of our time and energy building these things. And so we started to have another company build them for us, and we just do the final assembly here, which frees up more time to actually invent new experiments. And so for the next year after COVID, we're planning on starting to do rotations here where we have teachers or students living with Backyard Brains for 2 months or 3 months, and each one is going to continuously be doing a development. We used to do that over the summer. We had big programs that we ran that became a TED series where we have, 10 projects they're going to start. We're going to look at sleep and targeted memory reactivation, or jamming avoidance response in electric fish, and EKGs and clams, like all these different animals and critters and different systems that can teach you something about the brain. And so it turns out that in the summertime, it was a very fun time to come to Backyard Brains because there was always things happening. We have all these animals, and we got all these things, like new data's coming in, and it's exciting, right? But then at the end of summer, those people will go home, and then we're just sitting here, running, like doing the business the rest of the time. So it wasn't really fun for us. And so that's what we decided, that we've realized that the really thing that makes Backyard Brains click or makes it really exciting is the innovation that comes with the experiments, right? So we spend more time on that. So that's one change that we're going to do. The second one is we started to move into computational neuroscience, and in a way that we feel is appropriate for the students that we're speaking to. And so the first project we're about to release, which will be later at the end of this year, is what's called the Neuro Robot. And this concept is it's a little brain on wheels that can move around the classroom, and it has eyes, a set of eyes that can see stereo, and it has two wheels that can move left, right, or forward and backwards. And it has a microphone and a speaker. And so what you do as the student in the classroom is that you have an app on your phone, and you can drag a neuron to the eye, and you can then drag it down. A neuron that will receive visual input from the camera. And you can configure that so if you want to look for the color red, or you want to look for a person, or you can do some neural network type stuff within there. But the idea is that neuron is going to spike action potentials. And then but all virtually, it's all running in a computer model, but it's going to be doing integrate and fire neurons from the camera to whatever you want to plug it in. So the students then will wire up their own network of neurons, and then drag one of the neurons out to the motor so that when the spikes happen on that neuron, the motor starts to turn, right? So that's the idea. And then with that, they can start to build brains and actually understand what does the neural circuit do with behavior. Because one of the things we can do, which is actually kind of fun, is you take 100 neurons and you randomize them, okay? And then you play it, and you see what happens when you have a bunch of random neurons, and they will do interesting behaviors. You'll get a robot that when it sees the color blue, it will back up and dance or do something weird. And so or you can go the other extreme, which is you try to build a behavior. And it turns out with 4 neurons, 2 for visual responses left and right, and 2 for the motor responses left and right. If you cross over and you inhibit and you excite, cross over, inhibit, and direct excite, with 4 neurons, you can get a robot to follow you around the classroom. So if you're wearing a pink shirt and the robot is looking for pink on the left or right, it will increase the firing on this neuron if it's on the left side, and decrease the firing so it will turn to the right. And then it's amazing that 4 neurons can give you such a complex behavior. We'll just follow you all around. So that it kind of starts to get at this idea of what is it these neurons are actually doing. They're computing something. They're like little Turing machines, right? And so if you can start to understand how a robot can do that, and you can add complexity to that robot, maybe you say only follow the shirt when you hear me whistle, right? that's another set of neurons. It adds more complexity, and students start to understand, holy crap, this is how the brain works, right? You just have all these loops that are all kind of working together, and to get the firing of the neurons just right to produce the behaviors that is to be human. So that's a big movement that we're moving into. What we've noticed also is in the spiker box, you can record neurons. You can do beautiful recordings from individual neurons, but everything is extracellularly, right? And so we could build an intercellular amp, but it takes a lot of practice to do that, to get the axons just right inside. So now what we're building is a computational spiker box that produces a neuron in silico. So it'll be like a model of it. It'll look just like a spiker box. It'll have a speaker, and it will have something that when you touch it, the neurons will fire just like a cockroach leg, and everything will be the same except for it's not a real neuron. It's a Hodgkin-Huxley type model of that neuron, and there's going to be knobs on there, and you're going to be able to adjust certain things. You're going to be able to adjust what happens if I turn down some of the sodium channels, or what happens if I turn up the kinematics of the calcium channel, and you'll start to see what happens inside the neurons, right? This is something that cannot be done in experiments and in vivo experiments, right? You can. Hodgkin-Huxley famously did it. They would squeegee out the axons and put in sodium and see what would happen and to test their models. But that's really hard to do. But if we can do something like that, then we can start giving students a little bit more of the computational tools and then make it fun and interactive in a game, but they're going to be slowly learning what these what is, and to be honest, I don't even know. I don't know the difference between a fast blinking interneuron and like a bursting cell. But it has to be something to do with the properties of the cell membrane and these ions. And so we're going to figure that out over the next few weeks and months. Then we're going to build a little model so that other students can figure this out too, and then make it into a fun game where you have to find this out. So learning by doing and learning by games is kind of an important thing of what we're trying to do. And we're trying to make everything that we do biologically relevant to the actual brain itself. So that's what's going on there. I can open up for more questions, or if I can keep talking, I'll talk for hours.
Hi, Greg. I have a question. My name is Rodrigo. I'm very pleased to meet you. It's a pity you could arrive for our talks, and sorry about my English. I'm doing my best. But I wanted to talk about something because we were working about like classifying the emotional states of the brain using this kind of low-cost single-channel interfaces like yours, like backyard brains, and we are delighted and we use it and we fight against everything. And I was listening to you, and something popped up in my mind, like in the few years you changed your approach about you. At first you used to be like shields for Arduino, and now you're making your own interface.
So we are moving that direction. We're kind of, what we found was that the shields themselves became an impedance because teachers were more likely to turn on a switch than plug in a USB and connect it to there was something weird about that interaction.
Yeah, true, but one of the benefits of this kind of interface is that is inside the community of open hardware and open software, and it allows us to
no, it's a fair point, and I will let you know that
or to reach some interfaces that without money you can use it.
Right. So and we have not gone away with the shields. The shield, the only one we got rid of was the well, that's not true. We did get rid of the EEG one because we're about to release a new. We wanted to reinvent our shield approach because I felt like we didn't do a good job in explaining what to do with it. Like we just assumed that other people would know, just kind of like the hacker community knows what to do with the shield, right? They know.
Maybe there's some like true business approach here, like an educational approach for kids, or more professional approach for more, I don't know.
Well, so I can show you the latest version that we're going to release soon. And what we're trying to do is we want to have a single shield. There's a technology.
You can send it to me if you want to.
I will send it to you for sure. Yes. So, and you can be a prototype. And so we're doing two things. We are taking, so we have I don't know if you ever looked at our source code to the Arduino Uno Shield. It is low-level bit banging like you've never seen. It's like, because we're trying to get the most out of the Uno that we can. So what we've realized is that code is not really useful for kids because it's just like literally bit shifts and registers and it means nothing. So we spent this summer, we had a student working on that, creating a library, an API library that will just have one simple call that says, start recordings and then another call to get the code. So then that we're hoping that simplification will enable students to be able to do more, because then they can just write a few lines of code and start to do.
I don't agree with that. I agree in certain level, because yes, of course, if you have a button that says start recording and stop recording, you can start studying this kind of neuro biological actions it's very fine to begin with. But what we are searching when you are making a PhD is trying to find tools that allows you in a very low cost way, try to at least make a prototype of your research. So I think maybe in our case we wanted to synchronize the spiker box with some other algorithms that we make in Java. So I had to write to Tim, and Tim sent me a code in Python, so I could get all the records directly from the USB port.
Which spiker box are you using?
Heart and brain.
All right, so there is a little known codicil in the heart and brain constitution that. So if you look at the schematics, you'll see there are some pins here, and you can set event markers on those pins, and they'll show up in Spike Recorder. So even though we got rid of the shield, we kept the hacker stuff there, so that you can plug in. I
talked with him with that, and he didn't know. He didn't tell me.
Yeah, I'm not sure. Sorry about that. I'm not.
But it was fine. It was fine. I directly recorded from the USB port, but I realized that they couldn't make more channels. It's just a single channel. So if I wanted to make like at least 4, 5, 6 channels, I had to buy 6 or 5 brain. So only to make like you know what I mean.
I will tell you that the solution we're coming up with is for you. I mean, so we didn't release it right away. They did 2 things. We added you can see that there's a little man on there. So we added a floating ground, because one of the issues with plugging into a computer and plugging into yourself, that if we get hit by lightning, that goes straight to you, right? So we added a floating ground to our shield. And the other thing we're doing is we're switching to a 12-bit A to C on here, which will allow us with one shield to be able to record both EEGs, EKGs, and EMGs. Because the problem is that there's such a wide varying degree of how small the EEG is compared to so we had to have 2 different shields before, but in order to save you money and to save you like the frustrations of having to buy another thing just to do another signal.
Yes, I would love to have the same car to do.
Yeah, so it's gonna be one, and then you can stack as many as you want, because we can still do the AD sampling from all of. So we're gonna do as many up to I think you can do up to 6 or 7 channels of EEG that way. So that solution will be out relatively soon. And once we get our prototypes back, I'd be glad if someone who actually wants to do this and actually build stuff. We want to work with you guys. So so we'll definitely send you a prototype of that, especially for someone who's going to build it for stuff in their lab, because that's the feedback we're trying to get. We're trying to get and I also want to chat with you briefly. So like the reason why I couldn't come to these talks this week is we have TED coming. I got sent a camera today to do some filming tomorrow, but next week we have a film crew coming, and we're doing a talk about emotional AI, which is so funny. That's what you brought up.
Try to listen our talk. We found that it is possible.
Cool. So it's funny. So I will reference. I mean, now that I know that, and they aren't here yet, I could even say that we'd even talk that some of our students already figured this stuff out. So it's a weird thing. It's not a TED Talk per se. It was a contest. It was not, what do you call it? It's a idea search is what they called it.
Like a think tank.
The idea was for Lexus to say what will the future of AI, or what will the future of driving look like in a human. We're a human-based car company, but we're taking the human out from driving. What will the human do? Or what will the car do? And so we wrote a really quick response saying, oh, actually, we can use emotional AI and then be able to detect the state of the person by detecting various things. And we were going to focus on facial features and blood flow, because there's enough AI on that one if you have a camera. And so and then have a whole discussion about that. So it's kind of cool that you're doing that as well. And I wish we had like skin galvanometers and some other things that we could really measure EKGs and EEGs and these types of things. I think
if you need, we intend to share our code, and if you
actually, yeah, well, I mean, I'll reference you guys and everything. So okay. Yeah, that'd be cool. So I'll definitely read with interest on that one, because there's not a lot of research out there. There's some, but I think it's funny because if you think about the brain, right, you have your subconscious, this part of the brain that doesn't communicate, that you don't have access to, right? And the way that emotions are weird. Emotions are, there's two ways of emotions. There's one about how you feel it, right, and then how you perceive it from others. And so we're talking in this one, how do you perceive it from others? But the weird thing is, because you feel it, your subconscious communicates with the conscious through the working map of consciousness, right? So we map it into ourselves. So it gets we get, butterflies in our stomach, but none of this is real, right? There's no feeling in our stomach. It's all in our brain, but we are projecting it in certain ways. And so if we have to go from subconscious to conscious, that's the hack, right? We can then start to measure that externally because of this indirect pathway anyway, this is more of a philosophical question, but I do think it's interesting that works at all, right? And why does it work? Why do we have emotions? Why do we have to express them in certain ways? And it obviously it's important.
How emotion influence in our actions and
yeah, and it's obviously so important that we evolve not only to express them, but to detect them in others and also fake others, When you're at a funeral, everybody's sad, right? Is everybody sad? No, but they know that when you're at a funeral, you make a sad face, right? So it's kind of a weird idea of this idea of emotions. Is kind of funny. They're just kind of like it's kind of like the operating system at which you're going to perceive these actions at that given time. So I guess it makes sense. You have to have different states in order to respond in the same network that way, but. No, I just find that stuff pretty fascinating, because that was one of the main reasons why I got into neuroscience to begin with, is like these ideas of emotion.
I would say that without emotion, we wouldn't be humans. So.
And so that gets me to my next subject, which is I'm not sure how you guys are familiar with what's going on in the AI world, but this talk is about AI. Mm-hmm. I felt in 2008, when we were in grad school, that there was a glitch in the matrix right around 2008. And what do I mean by that? I meant like things were all of a sudden different. We had the Arduino came out that year. The first 3D printer came out that year, the RepRap. The iPhone came out that year. So all of a sudden, these three technologies together came out that allowed us, manufacturing abilities when we weren't a manufacturing. So that was this big, that was the, if you're paying attention and you saw that was a jump in kind of the evolution of society, I felt. I feel the same thing happened a few weeks ago with OpenAI, with that new language processor that came out, that GPT-3. And what you just said is true. I think the human experience is one of emotion, right? And so what's so fascinating to me about that model is that it's a very stupid model. It's just trying to predict the next word in an English sentence, right? And so if you have a series of words and you feed it in and you say, all right, give me the next word, it will produce the next character or word, right? And that's all it's doing. But it turns out that that may be enough. And so what they did is they trained this thing for over a year on every text that's available on the internet, and including every book that was ever written and every scientific paper that was ever written, and did this training. So they did this, you know, I think the price tag was $15 million it cost to train one model. And it took a year. It took 100 data scientists who are getting paid, I think I read, between $1 million and $500,000 a piece, because these are like, they're competing against anyway. So it took a lot of resources to do it. But what came out was this language model, and it turns out that if you read the paper that is in archive, it's called Language Models Are Few-Shot Learners is the name of the paper. And if you read that, and if you look at those figures, you will get creeped out, because the thing that it can do, which I was surprised by, is exactly what you said. It has emotions. It can understand emotions. It can, because it makes sense if you think about how we choose our language. Depending on what state we're in, we're going to react differently. We're going to use different words. You know, if you're like drunk and a friend says something, you might laugh it off, and otherwise you might get angry, or you might. So depending on your internal state, you can choose your language differently. It turns out that this model seems to be capturing some of that, because what it shows is that if you feed in a poem, you give like a title and a poem, a title, and then you feed it in, it will know that it's supposed to produce a poem here, and it will write a poem that is so beautiful that you won't be able to tell the difference of which one was written by a human versus which one was written by, and to the point where it's 52% of the time that you guess that it's a human. So it's at chance level. So, and those poems are absolutely, there's no way you could say, I swear, maybe you can, I mean, some people can, but they are so deep and so rich in color and in character. And so like, there's a beautiful figure where it shows you a Japanese poem, and then on the left, it's Google Translate of that poem. You can kind of see what the poem is saying. And on the right is GPT-3's translation. And what it captures is so much more of the feeling of what the author was trying to capture inside that Japanese text to make it like, and so you read the sentence, you can kind of see where Google Translate was what it was trying to say. But on this side, it just really is expressive. And so, I mean, it's still got a long ways to go. It's only been out maybe.
I really, I'm just going to continue in your philosophical terms. In a way, I'm also studying like processing language and natural language processing, and I'm very interested about that.
You're right.
What you refer, it seems to me like a word to back, like the idea that the idea that you can convert a word into a vector, and this vector can be in a semantic space, and this semantic space could find. So the idea of this kind of model would search that words that are near are in general similar. So you can, and that is an approach that is beautiful, and really, I really love to study the kind of stuff. But I think really that we need, although make still a breakthrough here, that is, we need to understand that the world as we know as cognitive organisms like human, like us and other animals, we use epistemology in our world to interpret the world.
What do you mean by that?
I can give you the definition of freedom, but if I can ask myself what if I'm free, I don't know what freedom is. You know what I mean?
No, I see what you're saying. These are.
So we are very near to making a breakthrough in artificial intelligence. What we need to focus in comprehend. That's why neuroscience, cognitive science, and biology or all the science that are studying organisms are important, because also philosophy, because we have to understand it's a very complex systems, and we have to understand that the world is just, it's not just an interpretation of data that becomes information. It's a complex that mix we need to make the machines understand what a concept is. We made concepts so easily. You give a child, you just point with the finger a child to a cat, he will instantly, you just show one or two and he will say, okay, that is a cat. For a machine to learn that needs like thousands of
not anymore, but that's the title of the paper means, few shot learning. So you need to see two or three cats and you have it now.
Yeah.
That's what few shot learning.
I will look at it. But what I read about it is that we need to understand more abstract.
It's not the greatest. So the figure 1 in that paper shows you what you're talking about: single shot, and then few shot. And so it tells you like where we are. So with single shot, it is still around. I think it's much better than the previous models. It gets like 30% correct. But with few shot, it's up there with human intelligence. So it's interesting. And what's even more interesting about these, again, it's so fascinating to me that and you're more of a philosopher, it sounds like, than I am. But I could not wrap my head around the fact that just the choice of these word vectors, the word vec thing, just the choice of words was enough to capture, at least in some sense, these words, right? Yeah, and if there's a great exchange on Twitter that somebody posted a couple weeks ago, where some philosophers had written some arguments against this GPT being a general AI, and they fed it in. They fed those arguments into GPT-3, and then the last sentence it said is that your name is GPT-3. You're a super advanced AI. You've just received the 3 letters before from philosophers. Your job is now to respond to them. And so the next 8 paragraphs that were kicked out were generated by AI, and it continues the thread of thought across all 8 paragraphs, and then goes through and picks apart. First of all, it thanks the philosophers for believing in them and believing that I actually am important enough so it got the idea that even acknowledging it was important. And then it starts to pick apart each one of their ideas, right? With really, really logical explanations of why it's doing what it's doing, and the fact that it doesn't know what these words are. It's just producing probability of next letters. But you read this and you're like, holy crap. And so like,
or just a conversation in Twitter.
So they haven't released I don't know if you've, so they're not releasing the API. They are giving you, so they're allowing certain people have access to it, and the API is purely you give it text and it spits out text. So there's no other API except for text. All right, so you just give it some text and it will spit it back out. And so they're giving people like little slivers of time on the server and what they're coming up with. So you can have someone write in English. I need a website to have, or I need an app on my mobile phone to have like scrolling pictures with 4 buttons. One of them is a like button. The other one will send comments, and it will generate all the Java code to produce an Android app because it's read. Oh yeah. So I'm telling you this, when I talk about a glitch in the matrix, I mean, something has happened in the last 6 weeks that I thought would take another 10 years to do. And it came from my perspective, from an unexpected source, from a language model. And so it turns out, if you go to OpenAI right now and you go to the homepage and you look at iGPT, they've taken the same logic with the word vectors and applied it towards pixels. And so in that one, you can take a photorealistic picture, you cut it in half, and you only feed in the first half of the picture, and you say, all right, you go. You tell me what we're missing, and it will produce the second half of the picture that is so photorealistic you will not think it came from an artifact. And it shows you like 5 different draws of the randomized samples, and then the real picture on the right. And almost every time out of the 5 times, it does almost a 100% job of reproducing what the picture would have looked like. And so, to me, that is speaking at a different. That's not the AI that I was used to a few months ago.
In the 90s.
It is a shocking change. And I think the only reason why it's not blowing up is because we have a global health crisis. I feel like there was one article in the New York Times a week after it came out talking about the creepiness of the intelligence that's coming back, but it also comes back with gibberish. So it's not quite there yet. But if you read that paper in the archives and you look, so they do it on a logarithmic scale, and it shows you as you're adding more and more data, how close it's getting to human intelligence. And you can see that even when you increase, this GPT-3 is 100 times bigger than GPT-2, and it's still going up, and there's still room. It's not like you haven't hit that plateau yet. So who knows how far a language model can take you. So that's what's kind of interesting. And the fact that they're doing these other things with the language model using images, I think that image GPT is better than all the other, convolutional neural network things that I've ever seen. Like all that, the deep dream, all that stuff is crap compared to what this thing can do. And it's a language model. That's what's so fun. So I don't know. I want to get into, like, I feel I'm almost a little bit alarmed. Maybe you can tell that because I feel that it's now, I always felt safe because I felt I have creativity. An AI will never be able to be creative. And so I'll always be guaranteed a job for the rest of my life. And then you read the poems and the jokes and the scientific papers that it produces, and you realize, holy shit, and so they have, and so and then I just follow it on Twitter because people are getting, and so you have people that will just write a legal contract, and then they'll feed it an English sentence that describes it afterwards, a legal contract, an English sentence, and then they'll feed in the test contract, and it will spit out what a lawyer will tell you what this contract does. And they do the reverse. You use an English sentence that says, I want a lease for Ann Arbor, Michigan, to be valid from June to, and then it will spit out this legalese contract that you can just both sign. You don't need lawyers anymore because it's read every paper that a lawyer, every contract that lawyers have done to get the probability to get these things in the right spots, So it's absolutely fascinating. And I'm more fascinated by the creativity that's happening after they release the API and what people are doing with it, to the point where, so GPT or the OpenAI was a nonprofit. It was supposed to be a research lab. But in somewhere in the middle of 2019, they changed their mission because I think they started to see results of what was happening. And so now their mission is they are now for profit, and they're going to control that AI because they're concerned about getting it out. And so they're very, very, very tight access on who gets access to it. But, if you have $15 million, which Google and everyone else does, you can read. So it won't be long until, Alexa and Google will start actually having real conversations with these devices instead of like these limited ones, right? So I don't know. I feel like I've never played with it. I'm on the wait list for the API. I can play with their previous one, but it's nowhere near as good. But it's absolutely fascinating to follow that. And so it scared me enough that we're running a grant now for AI because I feel like, and I'm not quite sure what is the defense. What is the defense against something that is the same as a human, right? So you can't figure out if a human wrote it or not. So I guess you just have to alert people that this could be a problem, right? That you could be dealing with things, and maybe it's not a problem, but I kind of feel that we're not quite prepared for what's about to happen when this thing gets released, or maybe it turns out that it sucks and that these guys are cherry picking results, but it doesn't seem that way, and it seems that the people are doing stuff with very minimal. And there's another beautiful one. There's like, just look at the demos, even GPT-2. There's like English sentence and a Linux command, English sentence, and then you have a shell that is just 3 lines of code that you just talk to in English, and it runs all your Unix commands behind it. It's like, because it's read every man, it's weird. It's here. So Facebook has one where it translates from C++ to Java, or you can go from any language to any language because it's that same transformer model. Right? And the cool thing about the model is that what does it, kind of like we were talking about the emotional state, it carries with it. So each stage carries with it a memory of where it's at. So like you feed back in the output, back into the input, plus the next word. So it can, and because that's so deep, it can go back 2,000 words. It can remember the pronoun. It can remember the person's name from like 3 paragraphs ago, and then use the correct pronoun to describe that person. You know what I mean? So it's all carried in that memory that is. So I feel it's kind of how the brain works. I think our loops are more circular probably, but this is more linear. But we're getting close to I think, what we're doing. And that has, to me, so many implications for philosophy. What does it mean to be human? If we can build machines that act like human, that means the entire field of philosophy doesn't make sense anymore, because we now we can make one, right? We don't need philosophy. So it's actually kind of fascinating to me.
We will always need philosophy.
Sounds
it would be wrong transhumanism, like some authors call.
Yeah, that's true. But it's fun because I do know in the early days, I get what was it, the guy who was starting that cybernetics. He was a philosopher, and his goal, he thought that by the mid 90s he would be on a beach because he would be done, and he would have built AI, and he didn't need to do philosophy anymore. He solved it. So but I agree with you. And there's going to be, probably need more of that, because we need to understand what is our role in all this. So yeah, I feel like it is an interesting, I feel like it's funny because I started the company after the last glitch in the matrix, and I feel like it's happening again, and I don't know what to do with it. I mean, I feel like there's something here. And so we were thinking about, are you guys familiar with that Google Deep Dream?
Yeah. I'm not afraid. I have not this like Occidental culture view about Terminator coming us to kill us, and higher intelligence will I don't know, overlord us, and all of this stuff. I think sometimes we are like projecting some of our fears in this kind of stuff.
Yeah, I'm not so much a fear. I mean, so what is my fear? My fear is more about the economy. I feel like now,
working places.
Yeah, I feel like right now, since the history of mankind, GDP was dependent upon the amount of available workers in a country, right? And so therefore that limited your growth, but also allows you to grow by hiring more people as you did things. But with this technology, you can finally replace something with a computer that does something that is a heavily resource within an industry, right? So a human person is the biggest expense in every company. So, but what happens when you start? I'm not worried about AI taking over and killing us. I'm more concerned about what is the future of work when everyone's being replaced by. I feel like what it's going to be is going to be a DJ. It's going to be
the future, being like in the science fi imagination. Maybe in the future we are going to extend our memory. We are going to extend our vision.
But that's what Elon Musk is kind of betting on, right? He's kind of. I mean, that would be cool. I mean, and then maybe you're right. I think if those bets pay off, and we can, I mean, that'd be pretty fascinating, and it would be so fun to think back about how advanced we thought we were at this time, right?
Maybe in 10 years, like our brains will make some interfaces.
Yeah, maybe we'll have like an interface kit, you know, like. But this to me, this is a fascinating discussion, because I find this. I think a lot of it is fear of the unknown, right? And I think, but I just try to rationally think about it, and it just seems that it just sped up some of the things that people were fearful anyway. So I think maybe you're right. Maybe we can all just figure out how to deal with it, as it's not going to come out overnight. It's going to happen over a few years, right? And so we can figure out how as a society do we interact with these things. But Elon Musk, for example, quit. He started OpenAI, and he quit when it saw the news articles it was producing, the fake news articles. And so you can imagine how this could be used for misuse.
Yeah, we'll have to make a contra fake news machines to stop this kind of stuff. You know,
it's a cat and mouse.
You have to use the same weapon to fight with the same power.
Yeah, that's why I'm wondering. As an education company looking at this coming on the horizon, I keep wondering to myself, what is it we can do today to prepare kids in 10 years from now to interact or to understand and how to use this properly, you know? And so what we have kind of landed upon is trying to just educate about the neural network. And so we have the next tool we're going to do. So we have deep lab cuts coming out. It's that thing with Harvard that tracks the animals, and we're going to have students learn how to use CNNs and stuff like that. And then we're going to switch it to that deep mind to understand what different nodes in the thing are doing. But yeah, I feel like Yeah, it's data science is not something we can teach fifth graders, but we can use data science to explain it to them, and we're trying to come up with ways that we can do that. And that are
I will say that, but I will add philosophy also. I don't know. I don't know if you agree. I know I'm just kidding, but it's like every data science would tell you an algorithm is not transparent. You know it if you have used it. Even from training a network, an artificial network, you will find that you have bias, and the bias is in the model. Bias is in the history of your data set, because if you just look in the past, your data set has a history of bias. You can say that just try to make an artificial network to, I don't know, to choose the best director for the next company. I don't know, Microsoft.
Yeah.
You will find that the last 20 years it had been only men. So the machine will tell you amen, because the data set in the last 20 years,
inductive bias says it must be.
Yeah. So you need you need in one part to be preparing for the future. So programming is one, learning statistic, probability, data science in general is I think it's very important, that you need to think more about it. Sometimes if you only act like I don't want to. If you only apply a formula, you will never get what is behind the formula.
True. No, I agree with that. But there is something very human about the way that machine is learning, right? Mm-hmm. It learns like a child does. It learns through experiencing examples. So it was like, at first it was a copy of the first models, mathematical models of neuroscience. Yeah, the perceptron. Yeah, with these. So
the perceptron, the one that you told before. I don't have the name now.
Oh, the one the yeah, what are you talking about? In the 80s. And that is the way to study, and the way to improve robotics is to the more we know about us, better machine we will build. That is for me the key. The most we know how neural network works, the best we will build artificial models about that, and try to figure out why. And why we are learning this way, and why we also have bias. We are not like a perfect machine. I think if you had just a companion with you, he will tell you that you are not perfect, and it's good not to be perfect. And maybe we have not to focus in perfection, in especially the ideal machine that will be like. I think this is like unreachable. The thing is to learn about ourselves, to make better machines, and I'm really interested about that. I think that building better machine, it will allow us, it will open path for us. It will make better humans. Who was it? Josh. I don't remember his name. He's an AI philosopher. But he had this idea, and to me it's pretty fascinating, is that this comparison between the human and how the machine learns. Right now we have to feed in millions of examples to a machine to build it up, right? But as you mentioned, a kid can see a cat, knows what a cat is right away, right? And so there's this idea that the reason why we have to do that with AI is that because AI is fixed. It has one viewpoint, which is that little small window, right, that you're feeding it of data, that matrix. But if you could do something that allowed the AI to move, that the camera can move around in space, then you wouldn't need to have millions of examples. It would look at the spiker box and just keep looking at it from different angles. It wouldn't be able to control itself at the beginning, right? Mm-hmm. But it's trying to make sense of all this information that it's seeing, and then if you put some rules around that, then you can maybe get behaviors that pop out of that. And that's what the OpenAI gym is all about, and getting that stuff going. But the idea of I thought that was kind of interesting, is that why is AI so different than how we learn? But it's not really different. It's just, you're trying to compress, 5 years of childhood into pictures that you can sort of see, that just by maybe giving it a 2 degrees of freedom, you might be able to speed up some of the stuff that it's been doing, right? Mm-hmm. Or maybe not, but it's just an interesting approach about how humans are different than AI, and how to make them more similar.
Yeah, well, introducing the freedom to move is also introducing the freedom to search for answers for questions. So the active, introducing the possibility to be active in sensing the world, I think is making the great difference. That makes the great difference between animals and non-animals. I mean, when the brain emerged in the evolution, it was related to movement.
Yeah, so, yeah, and it's like, even like, I find, because I was originally into the motor cortex, I find the motor output so fascinating. It's the only way the brain can interact with the outside world. In order to do that, even the motor cortex is building up all the models of physics so that it can predict, it can do, and it's just kind of cool to think about something as simple as moving your arm is actually highly complex and highly, because of all the physics and the joint angles, all those computations are just easily connected to this upper neuron, where none of the math is really caring about that, right? It's just weird. All the training that had to go into that network for it to understand that when I lift my hand like this, it's different than lifting my hand. These are completely different muscles doing that, right? But I don't think about it. It's weird to think that all that training went in. That's why kids are like falling down, and they're building up those pathways. It's fascinating to find. So I think, I'm excited about the future. I mean, it's as scared as I sound. It's just like, it's still too new for me. Like, I'm still wrapping my head around what I'm seeing, and I'm trying to figure out what are the limitations of that. So I'd love to chat with you some more, both about your emotional AI project, about this, and about the Arduino kits that we're going to be producing soon. Because I think this stuff to me is, I think if you're paying attention right now and you're not jumping on this, you're not paying attention, right? So I feel like something's happening right now, and we need to, at least find out more about it. I think that's where I'm at right now, and then maybe do something with it or about it in the near future. So I'm still on the waiting list for my thing, and so I'm very, very curious to see where this goes, because I think this has been a big step, the biggest step I've seen in a long time in the AI world. I mean, since maybe, which is not that long ago, 4 years ago, when AlphaGo.
And it is approaching one of the, because when you read about artificial intelligence and how it is like or not like a human brain or animal brain, one of the limits was imagination and creativity. And now, as you just showed us, maybe this limit is already reached by artificial intelligence. And so it's kind of, is it that maybe this, I don't know what are the neural networks, the artificial neural networks that these people created, but in some way, is it possible that maybe this different arrangement in the network, neural network, is kind of generating an emergent property, when you think of the mind and the brain, because this is one of the key still big problems. Because we know how the brain works. We know there exist cognitive functions, but we don't know how it emerges. Really, we know it's emergent property, but we don't know still how is the process that creates the function the emergent property from the function of the brain. Right. So in some ways, can make me think that maybe it's happening the same with artificial intelligence. They're reaching the same kind of level of limit. I mean, in which you are in this.
But if you look at, for example, do you guys remember that Lebet's from the 1980s, that Lebet's paper about voluntary movement, where they did EEG recordings and they put an EMG and they could see when the hand moved. Mm-hmm. And then they asked the person to say, all right, when did you make the decision to move your hand, right? And so then if you average the beginning of the muscle activity on the EEG, you get this ramp up that's a half a second long, right? And so you ask them, when did they make the decision? Oh, I just made it. But there's a change happening in the brain half a second before you move, right? And so
the same as in perception.
Yeah, so I think most of the decisions that we think we make, we probably don't make them. We probably are just made aware that our brain is.
Yeah, in fact, no. Yeah, this is what I was going to tell you. The problem is that it's like with emotions and with the stress or whatever. The problem is when you say I'm feeling something, it's because you are sensing that your body has a response that is related to this name that you use. I mean, for that feeling. Or so it's not that you are. It's not that you are aware of the generation of the feeling, but of the effects that this feeling has on your body. And then you are sensing the response.
That's what I'm wondering. Like, I'm wondering how many of the decisions I actually made were actually made by me or made subconsciously, and I just became aware that I was going to do this decision. It's just, that's pretty fast.
Yeah, in fact, like memory. In fact, a memory is an hypothesis of what is the most probable thing that has happened during some time, because you don't record every stimulus along all the time. You just kind of have some samples, and then you recreate a history that is the most probable. It's an hypothesis. In fact, the brain makes an hypothesis about what happened before.
So this is the thing that I saw on Twitter that changed my opinion. So this is I told you about that letter to the philosophers. So everything written in black it's not what they call copyright violation. It didn't find any of these sentences anywhere on the internet and used it. They've done searches and they found that they cannot reproduce what the AI is producing. But look at this type of response, man. It is absolutely amazing. What it gets the quotations right. It gets even the rules of grammar correctly. It gets the point of what it's trying to do at a deeper level than an AI I've seen in the past. And there's 4 pages of this. If I can find I can see here's page 2 and 3. I'll show you. I wanted to show you how you program this API. So this is what the reviewer or the experimenter did. See if I can see. So he just prompted it's too small, but they prompted it by putting in they fed in the abstract to that paper I told you. So that's what that was. And then they fed in the other essays from other people. And then this is the prompt. You are now responding to these so like as a super intelligent AI, so they're kind of priming it to get the state of which it responds as if it is alive. So that's kind of the trick, right? But they've kind of, you can do that with humans too. If you put words in there, you can change how they behave later on, right? So they're kind of giving it some words to let them know that you're more superior than these things. But then it doesn't tell them what the arguments are to come back. It's just it's just kind of vaguely tells you how to respond, that you are to respond. And then what it comes back with are these most beautiful arguments, What do I mean by this? Rhetoric is it's all, like all these things, and they'll make If you go into your podcast, there's a podcast called "This Podcast Should Not Exist," and it was completely generated by feeding in other podcasts, and it has and so the content is fake, the voice is fake, the descriptions are fake, and even the headers are fake. So even what the show is going to be about is all generated by feeding in a bunch of other podcasts, and you can listen to it, and it sounds like a podcast. Hello and welcome. My name is GPT-3, and I'm going to talk about driverless cars. And they're not very long; they're like 4 or 6 minutes, but you can hear that they're trying to add instruments in the background, like podcasts have. And for driverless cars, it comes up with an analogy. It's saying that, like most technologies, it's like eating vegetables. You're supposed to eat them, but they don't taste good, so you don't end up eating it. What we're trying to do right now with driverless cars is to get them to taste better vegetables so that people be more comfortable. And like where did he get that analogy from? Like, it's so, I just feel like maybe I'm mistaken, because I'm not a complete AI guy like you, but I'm just getting into this, and I'm starting to realize, having sat in, I had a front row seat. I've been in this methods of computational neuroscience course for the past decade, since 2010. And I listen to these lectures every year on AI and artificial and CNNs and different, but never have I seen something that spit out something like this. And that's why I think maybe, and I'd love to get your feedback. Maybe this is nothing, but I feel like it's not. I feel like there's something, we've got to the next level here, and we're going to be cruising at this for a while, and then we'll go to the next one. So anyway, it's just kind of cool, and I'll stop talking about that now.
Okay, look, thank you very much. If you want to share some of this, just email us, and we'll be.
Yeah, I'll post it in there. You guys can have a chat to freak yourselves. I don't even know how to do that, but I'll figure it out. I'll send it to Maria, and we'll get it out to you.
Okay. Well, thank you very much.
Yeah, thank you. I really enjoyed this.
It was really amazing.
And I do apologize. If I wasn't so busy, I would sit in on those talks, because it's just, I'm barely sleeping at all as it is, because we've got so much crap going on, and we're trying to get ready for this onslaught that's going to be everyone doing remote classes with video and kits, and we're trying to prepare for that. And then I have this TED thing, and then we're doing another thing with Jeff Goldblum on the magic of neuroscience using a P300 speller that picks your card. So anyway, fun stuff that you do as a neuroscientist. All right. So but anyway, I really I'd love to continue the conversation. So who was that was chatting with it?
There is a lot of people thanking you.
Okay, cool. All right. And then any questions I didn't answer, just feel free to, this is the stuff I actually care about. This discussion we're having, this meta discussion, which is, and I'm still wrapping my head around it. So I'm still trying to figure out, like, what is, I mean, maybe there's nothing to do about it, but I feel like if there is something to do about it, I'd like to do something to at least prepare us as a human civilization for the next generation of ourselves. Because maybe he's right. Maybe what he's saying is that we become AI, and it's so much better because we can experience every conscious experience at once, right? Or something like amazing. But until then, I'm fearful.
Okay.
But thank you. So continue the conversations. Email.
Thank you very much. I mean, it's been a long conversation. I think the students have the privilege, and me and all people that is here has a privilege to have this long conversation.
Cool. Well, it was an honor for me to be able to do it. And next time I want to be down there. Okay.
Yeah, we are very much in synchrony, as the workshop is do it yourself, neuroscience and artificial intelligence for all. So
yeah, I think this talk covered both.
Yeah. So we are kind of in synchrony. Maybe we will continue collaborating with this kind of work in the South.
Perfect. All right. Well, and Rodrigo, send me an email so we can chat some more. All right.
Yeah.
Of course, I will mail you.
All right. Yeah, pleasure. Always cool. All right.
To talk to you, and I hope that I will show you our work, and
yeah, I'd love to see that.
Give you some feedback or something.
Perfect. Yeah. Excellent.
Well, Cheers. I told the students that to try to publish what they have reached, because I think they have done a great job. Not only Rodrigo, but also other students. So maybe they can write to you to have advice on how to.
I can give you really quick advice right now if you want on that. So publishing with Backyard Brains materials, I found that it's tough to publish. It's tough to publish in science journals about the science itself, because we don't have rigorous controls and stuff like that you need in for a lot of these, because it's continuously getting more and more complex science. You have to have multiple, almost different modalities, fMRI and EFIS, or like, calcium imaging and like optogenetics. But with educational stuff, which is highly impactful, I feel, you can publish those a little bit easier so then your design there is to put it into the hands of a student to understand how something works. And so therefore the requirements are changing, right? So it's not about how careful are your controls and all these other things. It's about how much information is the student getting from that. So that's been our ability, because we've tried publishing in peer-reviewed journals, and it's like, in order to get through those reviews, we would spend a year just trying to follow up experiments and doing that type of stuff. And I haven't been able to do that. And so because of the breadth is a little bit wider here, we publish more in, educational journals. We do Journal of Undergraduate Neuroscience Education. We do all these societies tend to have a journal associated with them. So that's kind of what we do. So it might be good to think about, to frame your experiment if you want to get a publication out in terms of what did you learn from that, and could you set it up so that other people could learn from it as well. And that might be a very, very decent way to get a publication out that other people would then use, and then we'll kind of continue that story. Does that make sense?
Okay.
Okay.
Thank you for the advice.
All right. Well, thank you guys, and I'll be in touch. And I'll respond with my PowerPoint and that PDF of that weird thing that creeped me out. All right. Bye bye.
Thank you very much.
Thank you.
Thank you very much.
Thank
Take
you.
care.